Sagar sir, good evening.
Good evening, sir.
Do you want to test something?
I think if you are able to hear me, that should be fine.
Yes, I am able to hear, sir.
That's perfect then.
Oh, 1 minute, sir. Some resound is coming. 1 minute. Yes.
Okay.
Sir, our CEO, Dr. B. Ravindra Babu Garu, is also available, sir. And IQAC coordinator Satyanarayan sir is also available. Just a minute. Yes, sir. Surendra Babu sir also came, sir.
Okay.
1 plus 3. 1 minute, sir. If you want to test anything, you can test, sir. Otherwise, in a couple of minutes, we'll start.
From my side, I think everything is set, sir. We are good to go.
Sir, with your permission, shall we start, sir? Ravindra Babu, sir, Satyanarayan, sir, and Prasad Babu, sir. Sir, shall we start, sir? See you, sir. Satyanarayan, sir, are you able to hear me, sir?
I am able to hear your voice very clearly.
Okay.
Is my voice clear to you?
Yes, sir, your voice is very clear.
Okay.
Sagar, sir, is also okay. I think CEO, sir.
I don't know. See you, sir. Are you participating from office or from home?
Sir is also ready.
Okay.
So we'll start, sir. 1 minute, sir. Okay. Good evening, all of you. On behalf of Computer Science and Department of Computer Science and Engineering, Chalapati Institute of Engineering and Technology, I welcome you all for the 1-week national level workshop on artificial intelligence and its applications. So today we have distinguished guests with us. Our beloved CEO, Dr. B. Ravindra Babu Garu, CSI Regional Vice President for Region 5, Professor M. Surendra Babu Garu, Professor N. Satyanarayan Garu, Coordinator, IQAC, Chalapati Institute of Engineering and Technology, and our beloved resource person, N. Vidyasagar, Senior Manager, AI and ML, Salesforce India Private Limited. So I welcome you all on behalf of Department of Computer Science and Engineering, sir. Now, in this regard, I request our beloved CEO, Dr. B. Ravindra Babu Garu, to address the gathering. Sir, are you able to listen, sir? RB sir. Hello. RB sir. Hello sir. I think there is a voice problem.
Maybe he may not be able to hear your voice, perhaps.
Yes sir, yes sir. I just now 1 minute sir, I'm calling him.
కిరణ్ నాకు అసలు ఎవరు ఏం కనిపించట్లేదు. ఏంటిది? ఏంటిది మరి? మ్యూట్ కూడా అన్మ్యూట్లోనే ఉంది. నా వాయిస్ వస్తుందా ఇప్పుడు మాట్లాడేదా? అయితే నువ్వు మాట్లాడేది నాకు వినిపించట్లా. అదే ఒక నిమిషం. ఇప్పుడు 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 మీ వాయిస్ మీరు మాట్లాడండి
సార్. వినపడుతుందా సార్?
ఎస్.
ఓకే సార్, ఓకే సార్, థ్యాంక్ యూ సార్. ఓకే.
హలో.
Yes sir.
Shall I start it?
Yes sir, you can start it sir.
Good evening all of you. The speaker for the 1 week national workshop, Mr. N. Vidyasagar, Senior Manager AI&ML, Salesforce India Private Limited, and my colleague, HOD CSC, Dr. K. Kiran Kumar, and we have another distinguished academician here, the CSA Regional Vice President for Region 5, M. Surendra Prasad Babu Garu. Good evening to all of you. A hearty welcome to all the participants. There are about 1620 registrations. We are really proud of it, that 1620 registrations from 21 states and 5 countries across are participating in this 1 week workshop, which is from today to Saturday. And we are happy to introduce, we have a distinguished speaker here, Mr. Vidyasagar, who has 15 years of experience, and he is working for Salesforce as Senior Manager for AI&ML team. He started his career as an analyst and delivered projects involving business analytics, data science, and AI in healthcare and consumer services industries. He has a bachelor's in electrical engineering and executive master's from IIM Bangalore. And the other guest is the CSA Regional Vice President for Region 5, Mr. M. Surendra Prasad Babu Garu. And as all of you know it, this conference is for 1 week and it is on AI&ML. Maybe the speaker designated will be speaking on all those things, more and more details there. Mr. N. Vidyasagar. Just as a precursor, it is my duty to just take you to the topic for a while. All of you must be knowing that AI was coined by John McCarthy, an American scientist, way back in 1956. And in this 64 years span, it is an umbrella, rather to say, which includes a spectrum of, why spectrum? Everything, which it is encompassing everything, right from the robotic process automation to actual robotics. And it can perform tasks such as identifying patterns in the data more efficiently than human beings. which is enabling the businesses to gain more insight out of that data. And as you all know, it is the simulation of human intelligence process by machines, especially computer systems. And if we go on listing those applications, in fact, the conference title is Artificial Intelligence and its Applications. I don't know how Mr. Vidyasagar is going to manage to cover all the applications within a week. He will be finding it that difficult to see that he is able to cover about 6 into 1.5 hours durations, all the applications. Why? Because the list is that big a laundry list there, applications. So I request the N. Vidyasagar Garu to cover from this end to that end, and wherever it is required to be brief, and but to give the entire comprehensive overview of the applications. And I request all the participants who all have registered for this, please do attend for all the 6 sessions. Otherwise, you will not be able to follow. Where you are not able to follow, you will not be able to learn the things that are intended. So kindly be on the net, be for this 1.5 hour every day for this week, and reap the benefits of the expertise that N. Vidyasagar is going to share with us. Thank you, sir. Thank you once again, Vidyasagar Garu and Surendra Prasad Babu Garu. And I must congratulate Dr. K. Kiran Kumar for identifying such a senior manager in AI and ML and identifying such a beautiful topic, or rather to say, the contemporary topic, artificial intelligence and its applications. Thank you all. Sir.
Thank you so much, sir.
Vidyasagar Garu.
Thank you so much, sir. Now, I request CSI Regional Vice President 5, Professor M. Surendra Prasad Babu Garu, to address the gathering. Sir, your voice is not audible, sir. Surendra, sir, your voice is not audible, sir. One minute, sir. I am making a call to sir. Sir. Yes, sir. Yes, sir. Yes, sir. I am not able to hear you, sir. Now you are muted, sir, actually. But previously you are unmuted only, but I'm not able to listen, sir. Your voice is not. Now you are in mute condition, no, sir. No, sir. You are muted, sir. You are muted. Oh, okay. You are speaking with me. Maybe it was unmuted, sir. But I don't know. Your voice is not audible, sir. Sir, are you able to listen me, sir?
Kiran.
Sir,
Sir will join afterwards. Let the speaker start it.
Okay, sir.
Why the participants and the speaker should wait?
Oh. Just one time I will ask him, sir.
Okay.
Surendra, sir, are you able to listen, sir? Surendra, sir. Maybe there was issue, sir. Sir joined from the mobile. No, sir. Sir voice was not audible. So we will proceed with the next person. Now I request Professor N. Satyanarayan Garu, Coordinator IQAC, to speak a few words.
Welcome. Good evening to all the. Kiran, my voice is clear, isn't it?
Yes, sir. Your voice is clear.
Welcome all the participants for this national workshop on AI and its applications. And our CEO has already given a brief introduction about the importance of artificial intelligence. And Chatbot Institute of Engineering, we are always in the forefront of innovation. They have already started a branch in artificial intelligence in addition to the computer science and all. So all of you are aware of the importance of artificial intelligence. The only point I want to add here is this is a multidisciplinary activity. Many of you might have already participated in various fields where this artificial intelligence is there. As an example, on the other day, we have participated in a mechanical engineering field where the artificial intelligence plus 6G technology both are used, so that experts will be there in one country, and whereas the actual factories will be there spread throughout the world. And then with the limited people and all, we are able to run the factories, and one virtual factory will be running in one location, actual factory will be there somewhere else. So like that, a lot of developments are there. My only request to all the participants is, people in different fields, you may be already be working in artificial intelligence. Let us have a good interaction with our speaker, with Mr. N. Vidyasagar. He will be telling perhaps all the important application, but respective people from your area, wherever you are having some new ideas or wherever you want some clarifications and all, like that, if we have this interaction, we will be having a much better idea of how the artificial intelligence field is developing in India as well as abroad. This is the only point I want to say, that all people please actively participate. And I once again welcome all of you for this weekly workshop. And then Mr. Kiran Kumar, and then I want to thank you very much for arranging a nice workshop, which is more useful for all the people. And also it is a very convenient time, because from academics, both students and faculty, after completing their academic work, they can come home or they can in their offices and all participate from 5 o'clock to 6:30. And I hope all the people will be able to fully utilize this opportunity. Thank you,
Yes,
Kiran
sir.
Kumar.
Thank you so
all
much,
the
sir.
participants. Okay.
Thank you so much, sir. Sir, Surendra sir has joined again.
Okay.
Surendra sir, are you able to listen, sir? Surendra sir.
Hello, are you able to hear me?
Yes, sir. Yes, sir.
Yeah. Okay,
Sir.
thank you.
Now you can continue, sir. Thank you.
Okay. Shall I speak now?
Yes, sir. Yes, sir. Yes,
Okay,
sir.
okay. Good afternoon. The chairman of the Chatbot Institute of Technology, Dr. B. Rabindra Babu Garu, HOD Dr. Kiran Kumar Garu, and Professor N. Satyanarayana, convener IQAC, and the today's speaker, Dr. N. Vidyasagar, and participants. Good evening, everybody. I am very glad that the Chatbot Institute of Technology is organizing a one-week workshop on artificial intelligence and its applications. artificial intelligence and its applications. The area of artificial intelligence is my pet subject. I taught this subject more than 20 years in Andhra University Engineering College. So I'm very glad for this opportunity. The Computer Society of India is a 55-year-old professional society established in 1965 at Hyderabad. Presently, it is having 8 regions, more than 80 chapters, and more than 500 student branches with headquarters at Mumbai and education headquarters at Chennai. Region 5 is spread over 3 states, namely Karnataka, Telangana, and Andhra Pradesh state, with CSI chapters at Bangalore, Mysuru, Visakhapatnam, Vijayawada, Gunturu, Koneru, Ongolu, and Hyderabad. There are about 362 student branches, 125 student branches in Karnataka, 144 student branches in Andhra Pradesh, and 95 student branches in Telangana. CSI is regularly organizing different professional activities like monthly professional meets, seminars, workshops, expert talks, awards, professionals publish newsletters at chapter levels. CSI also organizes student contests, seminars, professional meetings, expert lectures, conduct interactions with academic and industrial experts and student branches. CSI organizes National Annual Convention, National Annual Student Convention, Regional Convention, Regional Level Annual Student Convention, State Level Annual Student Conventions. CSI recognizes people and institutions and present professional awards, academic awards, service awards, and presented in its national and regional and state level conventions. CSI YITP award is one among these awards. Apart from these, CSI also recognizes Best Accredited Student Branch, Largest Student Branch, Best International Student Event Host Award, Longest SBC Award, Maximum Publications in CSI Journals Award, Maximum Student Publication in CSI Journals Award, Highest Committed Student Branch Award for student branches. There are other popular awards are also there, and CSI publishes CSI Communication, a popularly monthly journal in which all the activities of student branches. There are about more than 1 lakh student members are there in CSI. CSI chapter activities, in 80 chapters, we have more than 30,000 senior members are there, and national activities every month. CSI other publications are ICT Transactions, CSI Adhyan Journals, CSI Journal of Computing, etc. are very popular journals. I am very happy to associate with the Chalapathy Institute of Technology in inaugurating this 1 week workshop on AI and machine learning, AI and its applications. When we just speak about the artificial intelligence in 1950, and for artificial intelligence deals with the problems that associated with intelligence. Intelligence is identified by a test known as a Turing test. In 1965, Alan Turing designed this test called Turing test, just like imitation of games. And when you just consider here artificial intelligence problem solving process here is divided into 2 parts. Whereas programming, it is only a single part. Here 2 parts. The first one is the inference engine and a knowledge base. In addition to this inference engine and knowledge base, we have here 2 parts, that is input and output. Now, when in the all the 55 to 60 years span, this input engine input system has been came into modern techniques, that is for example batch processing and stream processing streams. Input to the AI system is coming with different streams. one stream may be in images, one stream may be data, one stream may be some text, one stream may be some only some code or images, etc., etc. So we have to club all these things, that is, and then store here in the knowledge base. So and again here for the output, we are here explanatory AI is used for retrieval of this information. I'm very happy to associate with this program, and I congratulate Mr. Vidyasagar and also the Chalapathy Institute of Technology for making this 6 days program on AI and its application. Thank you very much, and and I thank you very much for giving me this opportunity. Thank you. Over to Kiran Kumar.
Thank you so much, sir. Thank you so much for your wonderful speech, sir. On behalf of Department of CSE, I thank our management, CEO sir, Dr. B. Ravindra Babu Garu, Principal Dr. M. Chandrasekhar Garu, CSI RVP 5, Professor M. Surendra Prasad Babu Garu, IQSC Coordinator Professor N. Satyanarayan Garu, our faculty and students for giving this opportunity and allowing us to conduct this workshop. Last but not least, I thank Vidyasagar Garu for accepting our request and coming as a resource person for this workshop. Thank you, sir. Thank you so much for accepting our request and coming as a resource person for this workshop. Sagar sir, over to you.
Thank you, sir. Thank you, Kiran sir. And I would like to thank everyone who have just spoken about the importance of AI and how AI is one of the leading technologies in the industry currently. So today, what we are going to see as part of this workshop is, I would want to take all of you through how AI is being used in the real world, how AI is making the difference in building some of the cutting edge applications that many of us might already be using it, just that we are not aware of. So with that, with no further delay, let's deep dive into what we have in store for the next 1 week. Let me share my screen first. Sir, can you confirm if you are able to see my screen?
Yes, sir.
Okay, fine. Thank you.
Thank you.
So before we start, a couple of instructions, because we have a large pool of people and I would definitely love to have interaction with each one of you, especially interacting with academicians and students is always a pleasure for me. We work in the industry. The kind of people that we see here versus the academicians are always going to be different, and the questions that I get from academicians always makes me to think, put more thought, give fresh ideas. So that's what I'm always look that I will always look for when I actually speak to the academicians. So in that sense, I would always love to interact with all of you. Because we have a large pool, it would be slightly difficult to interact with you in real time. Please feel free to post your question, and I will keep a tab on all the questions that are pouring in, try to answer them at the appropriate time, or else we will hold on every day last 15 minutes just for the Q&A session. So at that time, you can ask your question, and we will have a one-to-one interaction going forward. So a brief agenda, what we are going to see here. I know many of you might have been through different workshops on AI or ML. Some of you might be totally new to this concept called artificial intelligence. You have never heard about what AI is, etc. So to make it useful, to make it very good for all the diverse audience that we have. We are going to have a very low level discussion on artificial intelligence and machine learning. Not like the hi-fi stuff starting directly with, okay, think of a self-driving car, etc., etc. Yes, they are the real world applications, the most complex applications of artificial intelligence, if we speak. But for a beginner, for someone who is very new to this concept of AI ML, what exactly is this artificial intelligence and machine learning? Where it starts? What are the building blocks of AI ML? Let's start with those foundations. And I will put a structure, whoever is interested to pursue their career in AI ML going forward, I'll give you a structure of how you need to proceed, what you need to learn for yourself, how you need to pace that learning, and finally you have a better outcome. And I want all of you to be part of AI practitioners or AI evangelists going forward. So with that in mind, I have kept the first day completely just to give you a overview of the basic blocks of AI and ML. On the second day, we will see a ML example. You might be wondering, we are calling this as a AI workshop. Then why are we speaking about machine learning here? Right? You'll understand in a while. Without a thorough understanding of what machine learning is, it's very difficult to understand the concept of AI in the real world. So the AI that we are using in the real world is probably a most enhanced version of machine learning itself. So machine learning becomes the foundational block for anybody who wants to even have a understanding of ML. Second, that's going to be the second day. Then on the third day, introduction to the neural networks. If you are already familiar with this word called neural network, you might be already aware of what it is. But how does a neural network work? How do we practically understand what happens in a neural network? So that's third day is going to be the crux of our discussion. Everything, the bits and pieces that get stitched together to make this concept of neural network, which is very, very critical for the understanding of AI going forward. And finally, the last 2 days, we will spend time in building a neural network and building an application based on AI. So that's going to be a packed agenda. I know it's very difficult because we only have 5 days and 1.5 hour sessions. And within this short time, it's very difficult to show you a lot of examples and also make you to understand what happens behind the scenes. So that's the reason I choose only one example, one application, but I want to walk you through every bits and pieces of it so that you understand what that application is, how that application is built. So that's why I'm going to focus on the core basics because it's a workshop. So we need to do a little bit of technical indulgence here to understand at the core, at the raw level, what happens in AI. So at a high level, if we talk about AI in the industry, okay, so you have already heard AI is not something that's something which is very new. It has been in research for like quite some time, since 1953 all the way we are in 2020. Throughout these many years, AI has evolved from a simple Turing test to a very complex system which can challenge human beings in some of the cases. So how is it possible? What is the building blocks behind the scenes which is making this AI applications as good as, or maybe not on par with human intelligence, but just below par with human intelligence? Okay, so to simply state, what is AI? AI is the capability of a machine to imitate human intelligence. And how it can imitate the human intelligence? Through learning. Like how we have built our intelligence. We have built our intelligence by starting our schooling. We learn a lot of things right from our first grade all the way to the graduation. And through that knowledge, we develop our intelligence. And that's what makes us to do some of the complex reasoning, some of the complex analytics, and some of the complex decision making. Now, if we have to make a machine capable of identifying such complex reasoning, identify some complex analytics, and make some critical decision making, how is it possible? How can we make a machine think and behave like a human being? That's all what AI is all about. There are many approaches to it. For example, in the earlier days, when we first speak of AI, training a computer to play a game like chess. How can we train a computer to play a game like chess? Because we need to take a lot of decisions when we are actually playing the game of chess. There are some ground rules which we have to follow, and based on the opponent moves, we have to make the right move so that the end goal, the final goal, is to win that particular game. And there is a definition of what a win means, right? So that's the goal. What we can do is help the computer with the rules. Hey, these are the rules that you need to follow in order to play a chess game. At a given instance, what is a valid move, whether you can make a move or not. So at a point in the game, there might be 10 possible moves for a player, be it you or be it the computer. Now, which is the best move so that the outcome, the final outcome of the game is in favor of that particular player, be it you or be it the computer, right? So this is what we call as the intelligence piece, the decision-making piece. How does a computer build that intelligence by itself? How can we make a computer think and make right decisions so that it achieves a particular goal, it achieves a particular outcome? That's exactly what we call as machine learning, the fundamental block behind the scenes of AI. So machine learning is trying to help a system, a computer, a mobile phone, or whatever it is, to make right decisions so that it would be able to create a desired output. How can we train these machines? How can we train these computers? So this is where a lot of fundamental concepts called algorithms came into the picture. Over the past 30, 40 years, researchers, academicians has developed a lot of algorithms through which we can train a computer so that they can learn, and from that learning, they can make some decisions and they can try to generate a desired output out of this. I'll give you a practical example slightly later so that you will understand that in a much better way. But at a high level, what is this concept called machine learning? Machine learning is all about helping a system or any device for that matter to generate a desired output by learning from some data. That's a simple term called as machine learning. And how is this achieved? We achieve this with the use of a lot of algorithms. But these algorithms has certain limitations. Each algorithm has its own limitations. When we have to learn something which is very, very complex in nature, for example, let's think about a complex problem when we are driving the car. As a human being, how many decisions will we make when we drive the car for, let's say, 10 kilometers? Innumerous. We might have made thousands of decisions when we drove the car for a span of like 10 kilometers, right? What type of decisions? Okay, when we see a red signal, we have to stop the car. When you see a green signal, you can move. When you see an obstacle, you need to apply the brakes. When you see an obstacle which is moving, you probably don't have to stop the car. You just have to slow down the car at some pace that you don't hit the obstacle, as long as you maintain a safe distance between the obstacle. The obstacle could be other vehicle, then you are good to go. So these are all very, very complex decisions. Our human brain is capable of making such complex decisions through a very, very intensive processing. You don't know how much amount of processing goes inside a human brain. So nobody can try to find out the magnitude of it. It's just like amazing. That's the capability of a human brain. Now, if we have to make a car to take all these decisions on its own, first of all, it should be able to see something. Like we have eyes. The moment we see something, we recognize those objects, and the objects will be kind of classified into what type of object it is. Is it a stationary object? Is it a moving object? What type of decision making that we have to do when we see that object? All those things happens in a matter of a split second in the brain, and it gives us the right instructions, and we behave based on those instructions. Now, is it possible to process that much amount of information and make a system to drive the car? For example, if we can fix cameras to the car, through the cameras, it would be able to capture the images, and we pass those images to a processing system where we identify what are the objects in those images, and based on those objects, what type of decisions that we have to make. This is very, very complex, right? Now, for finding such type of complex patterns, the traditional machine learning algorithms were not quite good enough. They had a lot of limitations. They had a lot of challenges. So to make these, to overcome these complexities, a new set of algorithms, which are called as neural networks, was introduced later. It was there in the research for a very, very long time, and there was a pause in between. The reason is neural networks are computationally very, very intensive, so we need to have very powerful infrastructure, be it the CPUs, be it your RAM, the GPUs, etc., to process that type of information. And those type of systems are expensive. So that's the reason neural networks, though existed on papers for a very long time, was not at all used practically because of those infrastructure challenges. But late 2000s, when infrastructure is no more a problem, a small computer has 8-core CPUs, 32 GB RAMs, and even a GPU, generally used for gaming computers. So even GPUs are available on very small laptops. So processing power was not a big problem than it was before. That is when people realized, okay, why not use neural networks to kind of train such, to identify such complex patterns in the data. So that is when another very popular cutting edge set of algorithms came into existence. We refer to them as deep learning. So if someone speaks about AI today in the year 2020, just remember that behind the scenes, this AI is being powered by machine learning, or even more complex ones called as deep learning. These are the two building blocks behind the scenes. If someone says, okay, I work in AI, I build AI applications, that means they are using machine learning. Most of the times it would be deep learning. In some cases, they can still use machine learning. So their main skill set is machine learning and deep learning. So any one of you, if you have to become an AI practitioner or an AI engineer in future, if you want to be an academician to kind of evangelize AI, the most important concepts that we have to learn is these two, machine learning and deep learning. So my entire focus for this workshop is going to be on these two topics. So what is machine learning? What is deep learning? How they are different from each other? When do we use machine learning versus when do we use deep learning? What is the building block behind a machine learning versus what is the building block behind deep learning? So that's the introduction. That's the high level overview of what we are going to learn as part of this exercise. Okay. Now, just to summarize all these things that we have discussed so far in a picture, because pictorially it's so easy to explain than using some very complex terminology, complex statements and sentences, right? Our brains are more powerful to process images than some speech or than some text. Whether you believe it or not, this is true, right? So that's why people say picture speaks more than 1,000 words. So a simple depiction of what machine learning is represented in this particular graph. So I'll explain what happens here. In general, when you talk about software engineering, when you talk about programming, the objective of that software engineering or the objective of that programming is you take an input, you process something, and you generate an output. Think of a simple program, okay? For example, sorting an array. What is the objective of this program? It will take an array as an input. It could be it could be of any length for that matter. And this program has to process that input. That means arrange the elements in the array in a sorted order, be it ascending order, be it descending order, and generate the output. This is the general programming that we have been learning for quite some time. And that's how most of us has started our careers, from learning, let's say, C++ programming or whatever it is. But when it comes to machine learning, it's altogether different. Why? In machine learning, we give both the input and the output. How does it make sense? How do I know what is the output? Right? That's where the trick is. We give both the input as well as the output, And we ask this machine learning, whatever is represented in that yellow box, we call this as the magic box or the black box. You do whatever you can do, try to figure out how you can generate this output from this input. So here we are not writing a program, or here we are not writing, developing a system which takes an input and generates an output. No, that's not what machine learning is. Machine learning is altogether different. It takes both the input and the output, and it will try to find out how can I generate this output with this input. And generally, in the common machine learning, this is represented as finding out a mathematical representation that can generate this output from the input. So that's why I simply wrote this as f of x. Let's say input is x. We want to find out a mathematical function that would generate the output O, so that we can write f of x is equal to O. So you have an input and you have an output. What we are trying to find out is a mathematical representation, a mathematical function that can generate the output using this input. So that's what classical machine learning is all about. Now let me give you an example. Okay, I have an image. Image can also be an input, right? So I have an image. The image is the image of a cat. In that image, in that picture, I have a cat. So the output is a system has to identify and tell us that, hey, this is the image of a cat. So my input is the image and output is the label which says it is a cat. So we give both of them to a machine learning model. If you are not familiar with what this term called model is, don't worry about it. We will figure that out in the next 5 days. So image is the input. My expected output is that a machine has to tell me that, hey, this is the image of a cat. Or let's give two images. One image is for a cat, another image is for a dog. So the inputs are two images, 1 and 2. The outputs are, one is a cat, the other one is a dog. So we give all of them to this machine learning algorithm. Now this machine learning algorithm has to figure out, has to identify the patterns that would guess that, hey, this is how a cat would look like. This is how a dog would look like. And that's what I am representing this as f of x. Some rules, okay? If it is like this, if it is like this, if it is like this, then probably this is a cat. Similarly, if it is like this, like this, like this, then this is a dog. So our input is those images and the labels of those images, and the output generated by this algorithm is those set of rules which would say, okay, if it is like this, then it is a dog. If it is like this, then it is a cat. When we learn these rules, what happens? This is the knowledge that we are seeking. So we store this knowledge. In future, whenever we have to make a decision, so that means we have an image now. I want to make a decision. Is this the image of a cat or is this the image of a dog? Now we apply that knowledge, those rules on that new image. And based on the output of those rules, we make a decision. Okay, when I applied these rules, it is saying that this is a cat, and I am going with that decision. So the guess here is, okay, this is a cat, right? So learning from your historical data. So what we are giving here as a input and output is called as the historical data. So we are giving some historical data which we know, and we are asking this machine learning to learn how this output can be generated from the input, learn those rules. This is the knowledge that we are looking for. Save this knowledge and use this knowledge in the future decision making. So whenever I give you an image in future, you use that knowledge and give me a decision. So that's exactly what machine learning is all about. So to just define it, machine learning is where a computer system is fed large amounts of data. See here, the input that we are giving to the machine learning, we are feeding large amounts of data. It then uses to learn how to carry a specific task. So in this case, what is this machine learning trying to learn? The machine learning is trying to learn how to generate this output from this input. And we are saving that rules, we are saving that knowledge for our future purpose, for our future decision making. That is what at a simple level we can define it as machine learning. Of course, this is probably the simplest of the definition that we can give for machine learning, depending upon what type of data we are giving, depending upon what volume of data we are giving. This whole process of learning can become literally complex. We would see that complexity later. For now, for us, we have an input and I have a desired output. I give both of them as an input to the machine learning, and I expect machine learning to learn how to generate this output from this input. And that is what I am calling as my knowledge base. Store that knowledge so that it would be helpful for us in the future decision making. Okay, so far so good. Fine. Then what is the difference between machine learning and deep learning? So far we have spoken about AI. What is AI? AI is making a machine or a system mimic human intelligence. May not be as good as a human being, because human brains are way powerful. We cannot really, a machine cannot compete with a human brain. Okay, but at least it should be able to take some very common decisions that a human brain can make. Like when you look at an image, you can easily say whether this image is a cat or whether it is the image of a dog. But for a system to differentiate whether it is an image of a cat or whether it is an image of a dog, it would be very complex. It takes a lot of training for a system to recognize the same. Okay, so that is AI. Next, what are the building blocks of AI? We discussed about the fundamental foundation layers called machine learning and deep learning. What is machine learning? Machine learning is giving input and output to a system, asking it to learn how it can generate that output with the input that we have given and store that as a knowledge so that it would be useful in the future decision making. So that's machine learning for us. How does machine learning happen? Of course, you need to make use of some algorithms. Like if I just dump the data into a system and ask the system to learn, it would never be able to learn anything. So it has to be coached, it has to be guided on how it can learn from that data. So that happens with a sophisticated set of algorithms. With the help of these algorithms, we can try to make a machine learn from some data, store that knowledge, use that knowledge in the future decision making. But these algorithms vary by their nature, their complexity, the way they work, etc. So the high level difference that we use in the industry when we talk about machine learning and deep learning is machine learning is based on a set of mathematical functions. Most of the machine learning algorithms is a combination of some complex mathematical functions, okay, and the way how they are being built in. For example, if you talk about, if someone says, okay, I use a machine learning algorithm to do something, they might be talking about the algorithms like decision trees, support vector machines, navy Bayes, bagging, boosting. So these are some of the very commonly used algorithms in the industry. And most of you even in the academia might be familiar with these terms called decision trees, support vector machines, and navy Bayes, right? So these are very popular algorithms within the ML fold. Then what is deep learning then? Why is it called as deep learning? Think of an image of a cat. Now, how can we identify patterns that can take the image as an input and identify it as a cat? Can we represent that in some simple mathematical form? Practically not possible. Even if we try to do that, the level of mathematics involved in there will be like way too complex, especially identifying patterns in images, videos, text is very complex than identifying patterns in structured data. So a structured data, when you have inputs like x1, x2, x3, x4 as inputs and y as your output, trying to find a mathematical relation between x and y is kind of easier. Okay, you have 4 variables, you call them as columns, you call them as features or variables, whatever the name it is, right? So using these 4 input columns, we want to find out a mathematical relation that would generate an output column. Though it is complex, yeah, we can try to do that to some extent. But when you give an image and try to find out an output, generate an output from the image, this might not be as straightforward as we thought of in the case of machine learning. So this is where we need very complex learning things, very complex learning algorithms, which can try to find out non-linear and extremely overlapping patterns in the data. If you are confused with this term called non-linear and overlapping patterns, don't worry about it. we would definitely understand as we go through the course in the next few days, right? So think of a cat image, cat color, cat eyes, cat features, the way the photograph is taken. Sometimes it might be taken straight where you could see both the ears and both the eyes. Sometimes it could have been captured from a side angle where you see only one ear and only one eye. So these are very complex things. So combining all of them to identify, okay, this is the image of a cat, is very easy for human eye and human brain, but very difficult for a computer. So this is where deep learning comes to our rescue. So deep learning algorithms is constructed using neural networks. So neural networks are capable of generating very complex patterns than most of the machine learning algorithms. So we are going to combine these neural networks to identify such complex patterns in the data, and through that we are going to able to learn how to come up with a decision, how to generate that output which is given for us. So if someone says, I am a AI practitioner, or I am learning AI, I want to become an AI practitioner or AI engineer, their main focus should be on these areas, like understanding how neural networks work, what type of neural networks are there, how many complex neural network architectures are there, etc. So this is going to be the main focus area for AI practitioners and AI engineers. But having said that, if one is not aware of what machine learning is and how machine learning works, it's very complex directly to go ahead and try to learn artificial neural networks. And that is the reason anybody, if they have to become AI practitioner, if they have to get into AI, the expectation is first they should understand the basic components, the basic concepts of machine learning. You don't have to learn machine learning thoroughly, not expected, but at least at a high level, we must understand what machine learning is. Then it makes easier for the people to go ahead and understand how a neural network works in reality and how we can use this concept called neural networks in building artificial intelligence applications. So these two are the main focus areas. If you want to learn, you have to first focus on what is machine learning. Try to learn machine learning at a very high level. Once you have a very good understanding about machine learning, then we would go ahead and try to understand the deep learning. So in this workshop, in the next few days, I will introduce you to one machine learning example. I'll give you all the details that you need to understand this concept called as machine learning. Then I will introduce you to neural network. What is a neural network? How does a neural network work in reality? What is the math behind it? What is the science behind it? Once you have a clear picture of these two, then we go to one of the AI applications, how we can build AI application using these techniques behind the scenes. Where are we using AI? What are the applications of AI? Of course, there are a whole bunch of applications, innumerable. Every industry has AI applications. But most of those applications fall into these three broader areas. So when we speak about streams in AI, so these are the three main streams that I generally see. The first mainstream within AI is called as the computer vision. Everything that deals with images, videos, etc., falls into this computer vision. So right from how an image is constructed, what are the frames used in the image, how can we separate the image into multiple frames, what filters we can apply, like taking the red out, taking the green out, taking the blue out, RGB, right? So everything is part of this computer vision. Then where is AI coming into the picture here, right? So AI is helping in many of these building these type of applications. You have a lot of image and video editing softwares today. Adobe Photoshop, so many of them, right? They do a lot of magical things. For example, I'll give you a simple example of image editing. Let's say there is a photograph of a person wearing some shirt. The shirt color is plain, let's say white, and we don't like that plain white shirt. So we want to copy a pattern from some other shirt and just paste it into the photograph. It's so easy in Adobe Photoshop. Now you take another image and you copy the pattern there and you just throw it. It would take that pattern that you have copied and exactly put that into the shirt of this new image. Anyone wondered how it happens? There are so many things that happens behind the scenes, right from identifying the area of the shirt to finding this new pattern and exactly placing that pattern on the right areas of the shirt. Everything is intelligent decision making. So all of these applications are built using a lot of deep learning models behind the scenes. How can we identify a face from the image? How can we identify retina of the image? How can we identify the posture of the image? All of these things can be done with the help of AI. That's why this is called as the image recognition or image processing, one of the biggest application areas of AI in the real world. Second is the natural language processing, another growing area. A lot of research is happening in this particular area. We call this as NLP, natural language processing, right? So this also needs very complex deep learning algorithms behind the scenes. For example, I'm sorry, so these things has to be changed, and I somehow missed it. In NLP, you have something like language transition. Google, if you cut and paste some other sentence of a different language in their search engine and ask for a translation, it will try to translate it into English or some other language for you, whatever the language that you ask for. Now, how does Google know how to translate this from one language to another language? That's a very complex language modeling that is happening behind the scenes, which is done through cutting-edge deep learning techniques. Chatbots, many of you might have already used it. Gone are those old days where you have a problem, you call a call center and you try to talk to them through the call center. Not anymore. Most of them provide chat support. You have a problem, you initiate a chat support, you type your problem and you get a reply. And do you think the reply is sent by a human being behind the scenes? No, it is sent by a machine. We call that as a bot, the chat bot, right? So the chat bot should be able to understand the sentence that you have typed in and sent, understand the context of it, and able to reply back with a appropriate reply. So that's one area where AI is definitely making a lot of progress. The service industry as well as the consumer industry is getting very good benefits from these applications of AI. Not only that, recognizing voice, recognizing speech. You have iPhone Siri, you have Google Assistant, we have Amazon Alexas, we have Google Homes. All of these devices are built using behind the scenes this NLP techniques to understand the language and able to take action on top of it. So that's why this is a very fascinating and growing area of applications of AI. in another fields, for example, if we talk about healthcare, healthcare is an industry, but everything application of AI into the healthcare industry, for example, medical image analysis, again falls into the computer vision area here, right? So by industry, it would change. The applications from one industry would to another industry would change. But most of the time, those applications would fall into these broader areas like the computer vision or the natural language processing. So these are the two very strong areas of applications of AI, and we are going to see a lot of new techniques, new applications built into computer vision and NLP going forward. And recently, I have been working with some of a couple of small startups, which is trying to leverage this AI in trading, like algo trading. Algo trading is a very old concept, using algorithms to trade. So if you are familiar with stock market, what happens in a stock market? You buy stocks, you sell stocks, you buy derivatives, you buy futures, right? So a lot of things happen there. You have to buy at the right time, you have to sell at the appropriate time in order to make profit. So if you don't buy at the right time, if you don't sell at the right time, we may end up with loss of profit, or even sometimes loss of the investment amount that we have made. So a lot of different trading algorithms has been there for quite some time, and people were using them to make their trading decisions, like when to buy, when not to buy, etc. But some of these decisions has to happen in matter of a split second. Sometimes the price might jump from, let's say, 100 rupees to 120 rupees in a span of a couple of seconds. And the moment it's gone, and you will not be able to buy it again at that price, right? So these decisions has to be taken in a split second, and then the trading also has to happen in a split second. So completely automating the trading strategy, like when to buy, when to sell, everything, no intervention or no manual intervention in placing the orders or in selling the orders, right? So is there a possibility to completely automate these trading strategies? So this is another area where in the recent past, I have seen a lot of people working to build deep learning based algorithms, to build AI-based algorithms so that they would be able to do a effective trading, automation of the trading, so that they get better profits out of it. Okay, that's some of the real-time applications that I have seen. I have built myself in the real world using deep learning, using AI techniques, image recognition, and then language modeling, algorithm trading, automated trading strategies. So those are some of the real-time applications that I have seen, that I have built using AI. With that, let's talk briefly about what is ML. As I said, without understanding what is this concept of machine learning, you would never be able to understand what neural network is or what AI does. So that's why we need to understand the basic concepts of ML. So to explain this concept, let me use a whiteboard, because I always love to explain things on a whiteboard. This is where we could freely express our thoughts. Let me give you a simple example of what machine learning is. Let's say I have a training data like this. We have X1, X2, X3, X4, and Y. X1, X2, X3, X4, these are called as the input variables. And Y here is the output or the target variable. So our intention of machine learning is when we pass this data to a machine learning algorithm, what we should get as an output is how to generate y using x. Let's say this is a function of x1, x2, x3, x4. This is a field where there will be a heavy involvement of mathematics. And being an engineering graduate myself, I was wondering in my first year, first semester, second semester, third semester maths, like, why do we need to even learn maths even after coming to engineering? What this math is going to do us in future? I never felt that. But after jumping myself into machine learning, I realized the importance of the first 5 semesters mathematics. All the mathematics that you are going to see comes from the first 5 years of mathematics that we have learned in the engineering. So this is a field where we see the practical applications of all those mathematical things that we have seen. Now, when you have this function, which is a function of 4 inputs, you would always generate your output y. So that way, in future, when someone gives you the values of x1, x2, x3, x4, I know how to generate y. So y is a function of all of this. So x2, x3, x4. It looks so simple on paper, but when we actually do it practically, that's when you realize the amount of complexity, right, that is involved over here. Now the question is, how can I generate this? What is the science behind this? So this is where we have to understand what type of algorithm can be used for a given scenario. Let's say I have a scenario where I am predicting y. Let's say this is resale price of a car. Resale price of a car. What I have to guess? I have to guess the resale price of a car. And what are my inputs? The inputs are the odometer reading, years of usage, model, then manufacturer, something like this. So given these input variables, what would be the price of this particular car? So that's what we want to predict, right? For this, we will start with some historical data. Let's say we take 1,000 observations of historical data. And we divide this historical data into 2 portions. This is called as the training portion, and this is called as the testing portion. So we use these 800 observations, roughly saying my training is 80%, testing is 20%, but doesn't have to be 80-20 all the time. Okay, just to give you an example, I'm saying 80% I am taking into training and 20% I am taking into testing. So these 800 observations, we will give that to a machine learning algorithm, and this algorithm generates a function f of xi, and using this function we are going to find out the values, what is the values of f of xi for these remaining 200 observations. These are 200 observations, right? So we will find out what is the output generated by our function for the remaining 200 observations. Let's say this is 2 lakhs. That means the car got sold for 2 lakhs, but the function we have learned is saying that this car will fetch only 1,80,000 rupees. There is a difference between the output and then the prediction that is generated by our function. If this difference is small, negligible, I do not have a problem. I am okay with this. But when this difference is large, I have a problem. That means whatever the function that we have learned is not really predicting the values of the resale prices of the car very well. So this is where we need to go back and try to learn again to get the right function f of xi so that the difference between this and this is negligible. This is an iterative process. We do it repeatedly so that we would be able to learn in such a way that we have very minimal difference between the output that is generated by the function and the value of what is there in your output. This is for one observation, but we have this for many observations, right? So we need to make sure that our output generated by f of xi is good for all the observations, not just for one observation. So to make sure, we have to use something called as error metrics. The popularly known metrics in this case are RMSE and MAPE. RMSE stands for root mean squared error. I will show you how it is computed. Root mean squared error. And MAPE stands for mean absolute percentage error. So these are the error metrics that we generally use to find out if the values generated by the function that we have learned is really close enough to the original values. If it is really close enough to the original values, that is when we stop and say, yes, our learning is good. So whatever the function that we have learned is able to generate the values which are very close to the original values. In future, we can use this function to generate those values. So in future, if someone gives us the values of x1, x2, x3, and x4, I can predict, okay, what would be the resale price of this car. So this approach that we have discussed so far is called as regression. Whenever your target variable y is a number, generally a float, then we use this regression. That means we can only use regression algorithms to learn how to generate this output from the input. So this is our output and these are our inputs. So how can we generate this output from these inputs? Now, how do we compute these error metrics? Error is the difference between original value and then the value generated by the function. Let's say y is our original value, y hat is the value generated by our function. So this is our error. And these errors, for each observation, we will get an error, right? So these errors can be positive or negative. So to overcome that, what we do is EI square. We are going to square the errors. So that's why it becomes squared error. On the squared error, we are going to apply mean of the squared error. That means what is the average squared error? Mean of squared error, because it is on a square term, interpretation is difficult. So let us bring that to common term by applying a square root. Root on the mean of EI square. So that is what exactly we call as root mean squared error. Indirectly, what it tells is when you are predicting the resale prices of the cars, on average, what is your error? If the average error is small, that means you are making very good predictions. If your average error is high, you are not making good predictions. So that's how we judge whether the algorithm that we have used to find out the function that can generate the output using these inputs is really making a good job or not. That's why these are called as performance metrics. These performance metrics are very important. When we go to neural networks, if you don't understand this concept of performance metrics, then it's difficult to understand the concept of the neural network itself. And for that reason, I'm just giving you a brief example of how we actually approach a machine learning problem. Okay, we have only a few minutes left, so I would pause here for today, and I'm opening up for questions. Even if it takes 10 more minutes, I'm more happier to stay back and answer your questions. Feel free to ask questions and let's make it as interactive as possible. I just want to ensure that if you understand this concept of machine learning well, then my job becomes much easier to teach what happens in AI. I'm open for questions now.
Any participants, if you want to ask any questions, either you can type in the chat box or you can unmute yourself. You can raise your hand so that I can unmute yourself. And the participants who are participating in YouTube, you can type the questions in the chat box and I'll post here and the resource person will answer all your queries.
When you say back-end coding, we use programming languages like Python, R, Julia, Spark to do all of this stuff. Python is one of the most popular programming language, especially in AI. There is nothing like a back-end or a front-end here because all of these learning process can be termed as a batch process. So you have some data, you are trying to learn something from the data and save that knowledge for future. So I would not call this as a back-end coding, but this entire thing is done with the help of the programming languages like Python, R, Julia, even Spark, etc. Yes, most of the time it is Python that is very popular here.
Vidyasagar ji, I would like to ask you one question.
Please.
What are the role of heuristics here in machine learning?
Okay, the heuristic-based learning was age-old AI, where we generally try to build a knowledge base using some preconceived rules, preconceived thoughts. For example, if you take an image, what could be the heuristics that we can apply on the image to identify whether this image is a cat or not? For example, if you say if there are two eyes and if the eyes is separated by a particular distance, if the eyes there are 2 ears, the ears are in a particular position. These are generally called as the heuristic rules. And through these heuristic rules, we can build a knowledge base and apply these rules whenever we are trying to learn and look at the performance. If the performance is good, then we can use these heuristic rules for our future decision making. But heuristic rules has limitations. It is as good as what we actually thought about the data. The way the features are represented, we can only limit ourselves to the features there. What happens when we use advanced ones like neural networks, etc.? They will try to find out much more complex patterns than the heuristics that we actually can think of. And that's the reason in the real world, today mostly it is a neural network or more complex pattern based learning approaches than the heuristic based approaches. But if you have to play a game of, let's say, chess, there a heuristic based knowledge base would still work well, but not with these type of examples that I'm mentioning now. Thank you. There is one more question called as reinforcement learning. Reinforcement learning is also one of the areas within AI, within the deep learning, where we repeatedly try to optimize something. So if you know something called as a traveling salesman problem, where you need to deliver something by covering the shortest path. Here, the objective is to find out the shortest path, not to achieve an outcome. Outcome can be achieved in many different ways, but the objective is to find out a path, achieve the outcome with minimum expenditure, minimum resource utilization. So that optimization using AI is referred to as reinforcement learning.
Sagarji,
Yes.
my question is whether, because when neural networks, pattern matching is also used here.
Mm-hmm.
And in pattern matching also we use a partial pattern matching techniques.
Yes.
So there also I think we may use this heuristics for processing the input fast. Am I correct? Or,
no. Neural networks are capable of extracting their own features. We just throw an image. What happens in the neural networks when we actually throw an image is it tries to apply a lot of filters on top of it and break the image into hundreds of frames. So this, if we try to do it manually using heuristics, we might not be able to extract the right features from the image, because we are directly dumping the image and asking the neural network to create those frames. A single image, let's say, is divided into 128 frames, where in one frame you have only R color, in another frame you have only green, in another frame you have only blue. So it will try to identify 128 such frames and use these frames as an input. If you have very good knowledge about how an image is constructed at a pixel level, what would be this, then you can use that heuristics to extract features from the image. But then if you are not really familiar with the science behind that image, if you do not understand that, it's always good to leave that job to the neural network so that they will be able to extract the frames for you, and then we can process on top of it. Even the processing can be many times faster if we go by that approach.
okay, thank you.
Welcome, sir. Real-time data streams. Okay, learning, as I always said, is a batch job. Okay, we learn from the historical data. So there was a question on how can we handle real-time data streams. Example is stock market given there. So learning does not have to happen in real time. For example, if we take the past 1 year data of the stock market, whether it is for a particular stock or whether it is for a particular index or whatever it is, you see how this stock has behaved in the past 1 year. And you expect that behavior to repeat in future as well. So when you learn that behavior in the past, you gain some knowledge and you are ready with your knowledge to make your next future decisions. So in future, you have gained something. Okay, whenever this happens, I see that this stock price is going down. So you have gained that knowledge. At this particular point, it reaches a stable point. There is no going further down. This is where I would try to place my order to buy. This doesn't have to happen in real time. This has to happen on your historical data. Then you make these decisions in real time. So you try to put that solution into an architecture which can make these decisions happen in a real time. But learning is always batch. We are going to learn through the historical data. There are certain scenarios in data science where learning can also happen in near real time, but not in this case, not exactly in the stock market case. It doesn't have to be. So the process in ML block is choosing a particular machine learning algorithm. For example, decision tree. When can we use this algorithm called a decision tree, where it takes input along with the output and generates the rules? Decision trees are rule-based ones, right? Generates the rules which can try to predict your output. When you talk about some other example, like in this case, the car resale example, in this example, you cannot use, let's say, the decision tree algorithm, because decision tree algorithm is not capable of generating this output from the input. You might seek another algorithm, let's say, for example, linear regression. So you use a linear regression algorithm here to where you pass this input data along with the output, and the linear regression will try to learn how to generate the output from this. That's exactly what happens in this ML block. Choosing the right algorithm for a given input through which we can generate the output. So that process is exactly what I am referring to as the training process. In the training process, you give input data along with the output data and pass that data to an algorithm that you have chosen, and that algorithm will try to learn how to generate this output from your input. Okay, if two equal AIs play a chess game, which one will win? Okay, this is probably the toughest question because this is hypothetical in nature. How can we say two equal AIs? That itself is difficult to answer. If they have been completely trained, completely monitored with the same process, if they are good, equally good in everything, probably that would end up in a draw. Unless sometimes even some small decisions can go wrong with one of that AI. I would not say go wrong, maybe not the right moves at the right time, then one of the AI might win. Otherwise, it has to end up in a draw, right? How do you use AI in digital image processing? So in computer vision, that's all it is about. How can we generate new filters? So in digital image processing, creating filters to identify something from the image is a very complex task. So in digital image processing, a lot of work is going on to identify such filters, to extract frames from the image. For example, identifying the face, identifying the structure, identifying the background and the foreground in the image. All these things are already done, but even more complex filters are being generated using AI in digital image processing. Real-time application is still way far away. You might not understand it right now. Once we learn something, you just have a knowledge which can make decisions for you. Now you need to build a system with a complex architecture that can take the inputs at the appropriate time, make the right decision. So this is this is more of a software engineering work. It is more of an architecture work, integrating all these applications together so you can use something in real time. Here, what we are talking about is how can we, first of all, learn and help a system to make a decision. We are still at the very basic stage, at the first stage. At the first stage, our intention is to make a system learn and make decisions on their own. Once we have that, then the second stage is how can we implement that into an application? For example, chatbot. First step is to train a chatbot. If someone asks a question, what answer it should give, that you have to do first. Then, once you have that chatbot ready, you take that and implement that in a customer service environment. For example, you have My Airtel app. You have a problem. You go to the chat window, invoke a chat session. The moment you invoke a chat session, behind the scenes, that chatbot has to kick in so that it would be able to answer your questions. So that is the product integration. I'm not talking about the product integration here. I'm still dealing with how to make all of you realize what exactly happens in the training process. If you are familiar with the training process, how each of these models can learn from data, then we would think about how to integrate into existing applications, existing systems. But we are not yet there. We are still at the basic level of how do we make a system to learn? How do we make a machine to learn? That's our main motive. You would see an example of what happens in the ML block tomorrow. I will show you a simple ML example. Then from the third day, we would dive into artificial neural networks, which is the most important concept that we have to understand. Which language is mostly suitable to design AI or ML? My favorite is Python. I would always vote for Python. But having said that, though Python is one of the most commonly used for AI ML development, Python do also have some limitations. The other programming languages which people are trying these days, something called as Julia, if you are not familiar with it. I haven't tried it myself, so I'll not be able to comment about it, but a few people said that is also good. Maybe in future we might see one more programming language that could be more efficient than Python, and people will switch to that programming language. But for now, for the time being, definitely Python is the leader there.
Yeah, any more questions? If you have any more questions, you please ask your questions. Otherwise, we'll wind today's session. Sir, we got a very good applause from the YouTube chat box, sir. All are saying that today's session was very good actually.
Thank you, sir. Thank you.
It was very clear for them. Most of them said that it was very clear for them, and they don't have any more doubts.
Okay, welcome, sir.
So maybe no more doubts. I think we can wind it up, sir, for today.
Yeah.
All the participants, sir, tell me, sir.
Tomorrow.
Yeah, all the participants exactly at 5 o'clock tomorrow. The session will again start. So the YouTube link is same, as well as the Zoom link also is same for all the participants. In the next 1 hour, the video, today's session video will be shared to you in all the groups. And thank you so much for your kind cooperation. Feedback link will be active for the next 10 minutes. So those who have not given the feedback, you can give the feedback for day 1. Thank you so much. And Sagar sir, thank you so much, sir.
You're welcome, sir. You're welcome.
Surendra sir, thank you so much for staying for the entire session, sir.
Okay. Thank you. Thank you.
Thank you, sir.
Okay.
Okay, sir. Thank you so much. RB sir, thank you so much, sir, for staying for the entire session, sir. Sagar sir, we'll meet tomorrow.